Hello everyone and welcome to the lecture on AWS Secrets Manager. So this lecture will contain all these topics. What is AWS Secrets Manager? Other types of secrets, pricing, authentication and access control for AWS Secrets Manager, AWS Secrets Manager access control, replicating AWS Secrets Manager secrets across regions, cross account access to AWS Secrets Manager secrets, AWS Secrets Manager integration with AWS Systems Manager parameter store, rotate AWS Secrets Manager secrets, and AWS Secrets Manager secrets managed by other AWS services. So what is AWS Secrets Manager? AWS Secrets Manager helps you manage, retrieve, and rotate various types of secrets, including database credentials, application credentials, OAuth tokens, and API keys throughout their life cycles. By using Secrets Manager, you can enhance your security posture by eliminating the need for hard-coded credentials in your application source code. Storing credentials in Secrets Manager helps prevent potential compromise by anyone who can inspect your application or its components. Instead of hard-coding credentials, you can make a runtime call to the Secrets Manager service to retrieve credentials dynamically when needed. Secrets Manager allows you to configure an automatic rotation schedule for your secrets, enabling you to regularly update and secure your credentials. By implementing automatic rotation, you can replace long-term secrets with short-term ones, significantly reducing the risk of compromise. With Secrets Manager, rotating credentials no longer requires updating your applications and deploying changes to application clients, as the credentials are no longer stored within the application itself. But for other types of secrets, so basically we have seen database credentials and application credentials, but for other types of credentials, this is the services which are recommended. So just to avoid some confusions, so for AWS credentials, use AWS Identity and Access Management. For encryption keys, use AWS Key Management Service. For SSH keys, use Amazon EC2 Instance Connect. And if for private keys and certificates, use AWS Certificate Manager. Talking about pricing, with Secrets Manager, you only pay for what you use with no minimum or setup fees. There is no charge for secrets marked for deletion. You can use the AWS managed key, which is AWS/Secrets Manager, created by Secrets Manager to encrypt your secrets for free. However, if you create your own KMS keys, you will be charged at the current KMS rate. So Secrets Manager service itself uses key management service called AWS/Secrets Manager, and that is by default this key is used. So if you are using that, you are not charged anything. But if you create your own keys, KMS keys to encrypt your secrets, then you will be charged the AWS key management service rates. When you enable automatic rotation, except for managed rotation, which I will talk about later, Secrets Manager uses an AWS Lambda function to rotate the secret, and you are charged for the rotation function at the current Lambda rates or Lambda price. If you enable AWS CloudTrail on your account, you can obtain logs of the API calls that Secrets Manager sends out. Secrets Manager logs all events as management events. While AWS CloudTrail stores the first copy of all management events for free, you may incur charges for Amazon S3 for log storage. If you enable notifications for CloudTrail, you may incur charges for Amazon Simple Notification Service, Amazon SNS. If you set up additional trails in CloudTrail, the additional copies of management events can incur cost. So now talking about authentication and access control for AWS Secrets Manager. AWS Secrets Manager uses AWS Identity and Access Management (IAM) to ensure secure access to secrets stored within the service. So basically we are trying to control the secrets which are there, which we have created or stored in Secrets Manager. So how to control access to them? IAM provides authentication, which is AWS IAM, which verifies the identity of individuals making requests to access secrets in Secrets Manager. Secrets Manager uses a sign-in process that includes passwords, access keys, and multi-factor authentication (MFA) tokens to verify the identity of users attempting to access secrets. IAM also provides access control, ensuring that only approved individuals who can perform operations on AWS resources, such as secrets in Secrets Manager. Secrets Manager uses IAM policies to define who has access to specific resources and which actions the authenticated identity can take on those resources. So basically this will take care of end-to-end life cycle. Basically who can create the secret, who can view, who can modify. So you can have secrets administrator policies, you can have user policies. So this will take care of starting from the creating secret, who can create, who can modify, who can use. So end-to-end life cycle of the secrets. It's handled via AWS Identity and Access Management Service. AWS Secrets Manager access control. So let's see how some of the workflow involved. So first is Secrets Manager administrator permissions. To grant Secrets Manager administrator permissions, you follow basically you add and remove IAM identity permissions and attach the following policies. There are two policies. You have Secrets Manager read and write and IAM full access. So both of them. This is for administrators. And next is permissions to access secrets. And by using IAM permission policies, you can control which users or services have access to your secrets. A permissions policies describes who can perform which actions on which resources. You can attach a permissions policy to an identity. Identity is basically your user group or role. And you can attach a permissions policy to an AWS Secrets Manager secret. Next is permissions for Lambda rotation functions. So Secrets Manager uses AWS Lambda functions to rotate secrets. The Lambda function must have access to the secret as well as the database or service that the secret contains, credentials for. So this is for automatic rotation. So the rotation happens through a Lambda function, which must have access to both the secret, which is in the Secrets Manager, and the target, which could be database or an AWS service. So both the places it has to access. So that's why it needs proper permissions for the Lambda rotation function. Then you have permissions for encryption keys. So Secrets Manager uses AWS Key Management Service, AWS KMS keys, to encrypt secrets. The AWS managed key, which is AWS/Secrets Manager, which is default to encrypt all these secrets. So the AWS managed key automatically has the correct permissions. So, but if you use a different KMS key, Secrets Manager needs permission to that key. So that in that case, you have to add the proper permissions. If you use your own key, like custom key, or you create a new key in AWS KMS. And finally, permissions for replication. So by using IAM permission policies, you control which users or services can replicate your secrets to other regions. So I'll talk about replication from one region to another region. So to summarize, we are talking about, let's say you have a root account. First, you will create some admins to basically give them ownership or delegate them. So they will be able to create secrets and all. So you will give them two permissions: Secrets Manager read and write, and IAM full access. So from that point onwards, they will attach proper permission policies to identity, which is basically user groups and roles, and they will attach policies to the Secrets Manager secret. So you create a user and let's say a secret, then you give proper permissions. And then for automatic rotation, you have to add further permission for the Lambda function. And if you have your own KMS key, then you have to add some more permissions. And if you are doing, this is optional, if you are replicating from one region to another, you have to add the proper IAM permission policies. Okay, replicating AWS Secrets Manager across regions. So you can replicate your secrets in multiple AWS regions to support applications distributed across those regions. Because Secrets Manager is a regional service, so if you are having distributed applications, so you have to replicate your AWS Secrets Manager, secret from one region to another. Replicating secrets across regions allows you to support applications that are spread across different AWS regions. By replicating secrets in multiple regions, you can meet regional access requirements and ensure low latency for your applications. If needed, you can promote a replica secret to a standalone secret and set it up for independent replication. Secrets Manager replicates the encrypted secret data and associated metadata such as tags and resource policies across the specified regions. Okay, next is cross-account access to AWS Secrets Manager secrets. So cross-account is let's say you have one AWS account and you have another AWS account. So how you will set up cross-account access so that you just create in one AWS account, but the another account should also be able to access the secret. So first is allow access in resource and identity policies. So resource is AWS secret and identity is user group or role. So to enable users in one account to access secrets in another account, cross-account access, you must allow access both in a resource policy and in an identity policy, which is different from granting access to identities within the same account as the secret. Use custom KMS key for encryption. So you must allow the identity to use the KMS key that the secret is encrypted with. The AWS managed key, AWS/Secrets Manager, cannot be used for cross-account access. Instead, you need to encrypt your secret with a custom KMS key that you create. So in this case, you have to have a custom KMS key if you have a cross-account access setup. And charges apply for creating KMS key. So there is a charge for creating KMS key, which is required for cross-account access to Secrets Manager secrets. So these three things are very important. First, you must create a KMS key for encrypting secrets, and then you have a identity and policy and resource policy, and there are charges for KMS key, and you just give permission to use the KMS key that the secret is encrypted with. So you have to give proper permissions. So first is step 1, attach resource policy to secret in account 1. The first step is to attach a resource policy to the secret in the account that owns the secret, which is, let's say, account 1. Step 2, you add statement to KMS key policy in account 1. So we are still in account 1. So next you will need to add a statement to the key policy for the KMS key in account 1 to allow access from the other account. So basically you allow from which account it should be open. So basically you are opening the door and you are saying this door account 2, which is some account number, can enter. And finally you have step 3, you attach identity policy in account 2. So finally you must attach an identity policy to the identity in the account that needs access to the secret. So this is in account 2. So in account 2 you only do one step, which is to add an identity policy, and this identity policy will tell what a user group or role can do, and herein you add that it should be that user group and role can access account 1 and access this particular secret. Okay, now AWS Secrets Manager integration with AWS Systems Manager Parameter Store. So Secrets Manager is dedicated to storing secrets, as we see, credentials and all. But there is another service, Systems Manager Parameter Store, which also has the capabilities to store secret. So let's see what is the difference. So Parameter Store, it has secure hierarchical storage for configuration data and secrets. So AWS Systems Manager Parameter Store provides a secure and hierarchical storage solution for managing configuration data and secrets such as passwords, database strings, and license code. So this is similar thing. Now let's see what is the difference. While Parameter Store enables storage of secrets, it lacks automatic rotation services. So this is the feature which lacks. There is no rotation of secrets, and AWS Secrets Manager fills this gap by providing automatic rotation capabilities for the stored secrets. And to leverage the benefits of both services, you can store your secrets in Secrets Manager and then reference them as Parameter Store parameters. Okay, and this approach, so basically you keep in Secrets Manager, but you put a reference in Parameter Store, which is in the Systems Manager feature. So this approach allows you to take advantage of the secure storage and automatic rotation features of Secrets Manager while using the Parameter Store as the centralized configuration management system. So when configuring Parameter Store to reference a secret stored in Secrets Manager, it is important to note that the secret ID in Parameter Store requires a /. So basically Secrets Manager, you have to have a / before the name string. So just have to add if you want to use with Parameter Store. And this specific syntax ensures proper integration between the two services. Okay, next is rotate AWS Secrets Manager secrets. So rotation is the process of periodically updating a secret. When you rotate a secret, you update the credentials in both the secret and the database or service. In Secrets Manager, you can set up automatic rotation for your secrets, and there are two forms of rotation. So first one is managed rotation. For most managed secrets, you use managed rotation, where the service configures and manages rotation for you. Managed rotation does not use a Lambda function. And next one is rotation by Lambda function. And for other types of secrets, Secret Manager rotation uses a Lambda function to update the secret and the database or service. So managed rotation, you don't have to do anything. You just configure a rotation like how often you want, and it will be taken care. So this is managed rotation for a service like AWS service or something. But if you have a rotation by Lambda function, there will be a Lambda function that you can see in AWS Lambda service, and that will be taking care of updating the secret as well as the updating the database or service. So AWS Secrets Manager secrets managed by other services. So we are talking about managed rotation. So let's see which all services use this managed rotation. So many AWS services store and use secrets in AWS Secrets Manager. In some cases, these secrets are managed secrets, which means that the service that created them helps manage them. For example, some managed secrets include managed rotation, so you don't have to configure rotation yourself. The managing service might also restrict you from updating secrets or deleting them without a recovery period, which helps prevent outages because the managing service depends on the secret. Okay, managed secrets use a naming convention that includes the managing service ID to help identify them. And it will look something like this. You have secret name format, for example, secret ID / my secret. So service ID. So this will be service ID, and it could be service ID could be one of them. So it is. So currently these services are supported. So basically you have so this service ID matches this one, and this is the actual service name. So just talk it out. This is AWS do data brew. So one is app flow. App flow is here. You have app flow, then a data brew, then you have data sync, and then direct connect, and ECS SC. So ECS, Amazon Elastic Container Service, events for event bridge. So the service ID will be events, and marketplace deployment, and OpsWorks configuration manager, AWS OpsWorks, and RDS relational database service RDS. Redshift query editor V2 and Amazon Redshift, and SQL Workbench is Redshift query editor. So all these secrets, all these services use Secrets Manager managed secrets. And that's all. Thanks for watching.